Hello everyone, I'm Fen Yang. In this video, I'm going to give a brief introduction of our paper, Efficient Model Personalization in Federated Learning via Client-Specific Prompt Generation. Recent success of deep learning lies in large-scale training datasets like ImageNet. However, such a large-scale centralized dataset is not always available. For example, in healthcare application, patient data contains sensitive information such as identity, which is private by nature. As a result, federated learning emerges as a potential training method that is able to leverage that information from all clients without exposing their raw data. To achieve this, federated learning algorithm like FedAverage chooses to share model instead of client data. At each client, the local models are trained using their private data. Then, the server aggregates each local model to construct a global one by average model parameters. Finally, the global model broadcasts back to each local client and start the next round of training. However, crucial challenges remain. The first one is the efficiency issue. Local clients like hospitals or edge devices may only have limited computational resources and communication bandwidth. Since FedAverage updates and transport entire model, this method restricts the use of strong backbones like vision transformer. If we update and transport such a large-scale model, it may cause heavy computation and communication workloads. The other challenge is the data heterogeneity exists among clients. The average model might not be desired for every client since it may deviate far from the local distribution, hence result in unsatisfactory performance. To address the first efficiency issue, we are inspired by the recent success of prompt learning to allow parameter-efficient client training without the need to update the parameters of vision transformer. In addition to the efficiency issue, the other challenge is data heterogeneity. Instead of simply averaging model parameters from all clients, we learn a prompt generator at the server as a hyper-network, which aims to generate personalized prompt for each client and would be trained by the feedback observed from local training. So in this work, we propose a client-specific prompt generation framework. At each client, we learn prompt vectors instead of the entire model to allow parameter-efficient local adaptation, to leverage knowledge among heterogeneous clients while achieving model personalization. At the server, we design a personalized prompt generation mechanism to produce and assign personalized prompt to local clients. To be more specific, at local training stage, efficient adaptation can be allowed by adopting prompt learning techniques. We keep the VIT backbone frozen and only update client-specific prompts and the classification head. In this way, the computation burden can be elevated and the client-specific knowledge can be captured by the learned prompts. With the prompt learned, the next question is how to explicitly learn information among all clients while achieving model personalization for tackling data heterogeneity. The goal of our prompt generator is to output personalized prompt for each client. To generate prompt vectors for a specific client, our prompt generator is realized by cross-attention mechanism that transforms a set of client-agnostic prompt bases conditioned on the client-specific descriptor. To learn this module, we use the optimization direction delta P to estimate the quality of generated prompts. Each module will then be updated by gradient descent and trend rules, since the prompt generator and prompt bases are updated by feedback from all clients. Knowledge sharing among clients can be allowed, and the client descriptor is only optimized by the corresponding delta P, so it is expected to represent client-specific guidance. In our experiment, we show that our method achieves promising performance on the domain shift setting, class-embedded scenarios, and medical image diagnosis tests. We further provide efficient study on our personalized prompt generation design. An analysis of the impact of the prompt number. In summary, we enable efficient model personalization in federated learning. This concludes my presentation. Thanks for listening.